Hello viewers, in today's session we are going to discuss another important problem from integrals, and in this session we are going to evaluate this integral, that is integral from -1 to 1, and the integrand is square root of 1 plus x divided by 1 minus x, and here we have dx, right? So here in this class we'll see how we can easily evaluate this definite integral using the concept of beta and gamma functions, right? So let us start. So let us call this integral as I, right? Now see, this integral can also be evaluated with the help of trigonometric substitution, but here we'll prefer the method of beta and gamma functions. So here by making a very useful substitution, we'll try to convert this integral into this form, that is 0 to 1, and we have say t raised to m minus 1 and 1 minus t raised to n minus 1 dt. So we'll make a substitution here, and will then convert this integral into this form, and this integral is known as a beta function, that is beta m comma n, right? So let us substitute here. X is equal to 2t minus 1. So this is the important substitution which we are going to use to convert this integral into beta function. So now when we take x is equal to 2t minus 1, then this integrand, that is square root of 1 plus x over 1 minus x, it reduces in terms of t like this, that is 1 plus x. For x we can write 2t minus 1, and here we have 1 minus x, so we can now write 1 minus 2t minus 1. So we can solve it. This one and this one get cancelled, and we are left with 2t, and here we have 1 minus 2t plus 2, and this is further equal to 2t divided by here we have 1, right? So this is 1 plus 1 is 2, and this is minus 2t. So let us take 2 common in the denominator. So we have 1 minus t. Now this 2 and this 2 get cancelled. So we have now square root of t over 1 minus t, right? And we can also write this expression as square root of t divided by square root of 1 minus t, and square root of t can be written as t raised to half, and here we have 1 minus t raised to half, and taking 1 minus t raised to half to the numerator, we have t raised to half, and then we have 1 minus t raised to a minus half, right? So when we take this substitution, x is equal to 2t minus 1, then square root of 1 plus x divided by 1 minus x is now equal to this expression. So now let us differentiate x with respect to t. So we can now write dx over dt is equal to the derivative, that is d by dt of 2t minus 1. So here the derivative of t is 1 and derivative of 1 is 0. So we have 2 times 1 minus 0, that is equal to 2, right? So we can now write dx is equal to 2 dt, right? Okay, now let us change the limit. So here the lower limit is x is equal to minus 1, and the upper limit is x is equal to plus 1. So when x is minus 1, then t can be calculated from this equation. So we have minus 1 is equal to 2t minus 1. So 2t is equal to minus 1 plus 1, that is 0. So t is 0 over 2, that is 0, right? And when x is plus 1, then the value of t can again be calculated from this expression. So we have plus 1 and 2t minus 1, and taking minus 1 to this side, we have 1 plus 1 is equal to 2t. This is 2 is equal to 2t, and t is equal to 2 over 2, that is 1. So when x changes from minus 1 to plus 1, then t varies from 0 to 1. So now let us write this integral in terms of t. So we can now write I is equal to integral from 0 to 1, because when x is minus 1, t is 0, and when x is 1, t is 1, right? And for square root of 1 plus x over 1 minus x, we can now write t raised to half, and here we have 1 minus t raised to a minus half, and for dx we can write 2 dt. So we can now take this to outside the integral, and we have 0 to 1 t raised to half, and 1 minus t raised to minus half, and dt. So let us write this half as t raised to 3 by 2 minus 1, right? Because here we have t raised to m minus 1. So we can write t raised to half as t raised to 3 by 2 minus 1. And here we have 1 minus t raised to minus half. So this can be written as 1. Here we can write half minus 1, and here we have dt. So now this integral is similar to this one, and if we compare this integral with this one, then the value of m is 3 by 2, and the value of n is equal to half. So now this integral I is equal to 2 times the beta function, that is beta m comma n. M is 3 by 2, and n is half, right? And to calculate the value of this beta function, we can make use of one important relation between a beta function and gamma function. So now we know that beta m comma n is equal to gamma m. Then we have gamma n divided by gamma m plus n. So we can now write I is equal to 2 times. Here we have m is equal to 3 by 2, n is half. So we have gamma 3 by 2. Then we have gamma half, and here we have gamma 3 by 2 plus half, right? Now gamma 3 by 2 can be written as half times square root of pi, right? So this is the value of gamma 3 by 2, and gamma half is equal to square root of pi. And here we have gamma 3 by 2 plus half, that is 3 plus 1 4 over 2, that is 2, and gamma 2 is equal to 1 factorial, that is equal to 1. So here we have used this result, that is gamma n plus 1 is equal to n factorial. So now we can write the value of I as 2 times. Here we have gamma 3 by 2, that is half square root of pi, and here we have square root of pi, and in the denominator we have 1, right? So we have I is equal to this 2 and this 2 get cancelled, and root pi times root pi, that is equal to pi, right? So viewers, the value of this integral is equal to pi.